Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video, we are going to talk about how you can solve real-world problems using the algorithms that we discussed earlier, which were ANN and KNN algorithms. And I'm also going to show you Python code for the same type of data set, the height and weight data set that we used in Random Forest. So we are going to apply Python code for the same thing, but this time we're going to be implementing KNN instead of Random Forest. So let's begin. First, we are going to see KNN in action, which means what are some of the examples in real life where you can apply the K-nearest neighbor technique. So K-nearest neighbor techniques for pattern recognition are often used for theft prevention in the modern retail business. Of course, you're accustomed to seeing CCTV cameras around almost every store you visit, but most people have no idea how the data gathered from these devices is being used. We know that there are CCTV cameras in all the stores, and you can see who is doing what. But how exactly do these cameras work? Is there something related to KNN behind these cameras? How do you prevent theft by these cameras? So now what we all imagine is that there is someone in the back room monitoring these cameras for suspicious activity, and perhaps that is how things were done in the past, right? That's what we think even today is happening. But today in a modern surveillance system, it is an intelligent system which is intelligent enough to analyze and interpret the video data on its own without a need for human assistance. So this is something surprising. You might be surprised to know that modern surveillance systems come with this type of intelligent video analysis software. So the modern systems are now able to use KNN for visual pattern recognition to scan and detect hidden packages in the bottom bin of a shopping cart at checkout. So that is truly amazing. The modern systems, they can use KNN, and using that, they can recognize the patterns, they can scan and see what hidden packages are there at the bottom of a shopping cart bin during checkout. And if an object is detected, that's an exact match for an object that is listed in the database, then the price of the spotted product could even automatically be added to the customer's bill. And while this automated billing practice is not used extensively at this time, the technology has been developed and is available for use. So nowadays, KNN is being used for this purpose to prevent theft and to just, automatically add the money, the price of that product into the person's bill. K-nearest neighbor is also used in retail to detect patterns in credit card usage. Many new transaction scrutinizing software applications use KNN algorithms to analyze register data and spot unusual patterns that indicate suspicious activity. So most of the time, people are worried about credit card fraud. And if you wanted to find out if there were any suspicious activities within the credit card of the person, you could use KNN to find such irregular patterns. For example, if register data indicates that a lot of customer information is being entered manually rather than through automated scanning and swiping, this could indicate that the employee who's using that register is in fact stealing the customer's personal information. Or if register data indicates that a particular good is being returned or exchanged multiple times, this could indicate that employees are misusing the return policy or trying to make money from doing fake returns. Now let's take a look at ANN in action, which is the average nearest neighbor algorithm. Now, as with other grocery stores, buyer behavior at a fictional Waldorf food co-op tends to follow very fixed patterns. So let's assume there is a fictional grocery store called Waldorf Food, and managers here have even commented on the odd fact that members of a particular age group tend to visit the store during the same particular time window, and they even tend to buy the same types of products. So this is something they have noticed. One day, manager Mike got extremely proactive and decided to hire a data scientist to analyze his customer data and provide exact details about these odd trends he had been noticing. So he's seeing that there are people who are coming at the exact same hour and buying the exact same things. And he wanted to find out more about such people, so he got a data analyst to analyze his customer data. And when the data scientist called Dan got in there, he quickly uncovered a pattern among working middle-aged male adults. They were visiting the grocery store only during weekends or at the end of the day on weekdays. And if they came into the store on Thursday, they mostly always bought beer. So then manager Mike was armed with all these facts, and he quickly used this information to maximize beer sales on Thursday evenings by offering discounts, bundles, and specials. Not only was the store owner happy with the increased revenues, but Waldorf Food Co-op's male customers were happy because they got more of what they wanted when they wanted it. So this was something really nice that happened because they were able to use ANN to find out patterns in their customers. And through that, they found out that Thursdays are good for selling beer, which is why they started trying to maximize the sales by offering discounts and specials and all on that particular product. So now let's go ahead and see how you can write just a couple of lines of code to implement KNN, which is very simple to do with Python library. So this is the same Jupyter notebook that I used for implementing random forests with Python with the library called sklearn. But I'm just going to quickly go over these statements here. So we have, first of all, importing the NumPy and Pandas libraries. This is our data set. If you would like to view this data set, I'll just show that to you once again quickly. So this is a height and weight data set, and it contains the heights and weights of several males and females. It's a huge data set, and it contains the height in inches and the weight in pounds. And the males are all represented by ones, and all the females are represented by zeros. You can see it at the bottom, all the data is about females. This one is about males. And so we are going to train our model to understand this. And then using that, we are going to try to predict some height and weight that we are going to feed to the model. So this code right here is basically reading this CSV file and just printing out a couple of lines, a couple of rows, like maybe the first 5 rows. And then we are using the Seaborn Matplotlib libraries to print this as a scatter plot. And you can see there is some category because the orange ones are males, blue ones are females. So you can see how the female data about females, how it is grouped closely together, and the males also. So you can clearly see some type of a classification or class forming here. Now, how to get this data ready to prepare it? Let me just run this code. So this code is done, and this is the plotting part. We could run that as well. And to prepare this data for training purposes, you would have to fetch the X and Y. So X is going to be all the columns from 0 to 2, and Y is going to be the label. So the label that we're talking about is male or female, which is our second column. So that is how we have assigned X and Y values. And then we would split the data set. So as I explained in my random forest video, to split your data set into a training set and a test set, Training set is the one that will be used by your model to learn, and the test set will be used by the model to test if what it has learned is correct or not, or up to how much percentage accurate it is. So to split your data set, all you need to do is to call this train test split function available inside the sklearn library, and just pass the x and y that you created and the test size. So the test size here is 0.3, which means 30% of the data will be considered as test data, and the rest of it, which is 70%, will be your training data. And random state is usually 0 when the test size is 0.3, when the test size is specified. So let's just run this as well. And now we are just importing from sklearn.neighbors k-neighbors classifier, which is a class available for performing KNN. So after importing, we'll just run it. And these cells are hidden because this is random forest, which we did earlier. So this is the code for once you have imported this, you want to create an object of KNN CLF, which is the KNN classifier for the k-neighbors classifier class. And then you will fit your x and y training data into this and then try to predict with the test data. However, since we are not measuring accuracy over here, you won't be able to see the results of this, how this is working. So what we did as last time, we are going to do the same thing here as well. We'll provide somebody's height and weight and see if it classifies the gender correctly. So this is the height and weight, height in inches and weight in pounds for Arnold Schwarzenegger, which I found on Google. And this is the same thing we used for random forest as well. And once I'm inserting this, I'm just trying to predict if this is male or female. So I can just run this and you can see it produces 1. So it is classifying it correctly. And we could go ahead and try it for some female as well. So the same as we used in random forest. So it is 157 meters, which I would have to convert into inches. So let's just convert that. .57 meters right here. It is okay, not 157, it is 1.57 meters, which is 61.81. Let's change them here. And the weight, I believe, was 52. So I'm going to once again get another one, LBS to kg. LBS is going to be, in this case, 52 kg. So we'll mention it here, and 114.64. And this should give me 0. So let's run it. It gives a 0. So it does correctly classify whatever we are trying to classify. So I hope you understood all these classifiers, and I hope to see you back in the next video. And thank you for watching.